Hi, everyone. Welcome and thanks for joining us today for the attack simulation webinar. I'm Anna Soslova. I'm on the field marketing team here at Cybereason. A couple of housekeeping items before we get started. All of the attendees are on mute. However, if you'd like to ask a question, you can do so in the chat. If we don't get to your question at the end of the webinar, we'll make sure to follow up with you afterward. We'll also be sending a recording of this webinar to everyone within 24 hours. In today's webinar, Sanat Chugh, our solutions architect, and Dan Petrillo, our product marketing manager, will walk you through an attack simulation. So Dan, do you want to take it away?
Sure, thanks, Anna. So before Sanat gets into the attack simulation, I'm gonna do a little bit of an introduction to what you're about to see and our product. So first, I want to talk about how the power of real-time correlation is a real asset for analysts who need to understand complex events that are happening in their environment at any scale, no matter how many endpoints they have. And by correlating and analyzing data in a graph database, we're able to present that information clearly to analysts and detect malicious activity in real time. So our product takes a layered approach to prevention, layering antivirus, which is the traditional antivirus using signatures, next-gen antivirus, which uses machine learning to pull out unknown malicious files, as well as behavioral anti-ransomware and behavioral fileless malware protection. However, today what we're going to focus on is actually all the events that occur after a breach when protection is not successful. So that's where the endpoint detection response, the data correlation, and the triggered alerts are going to come into play. One common issue in the world of cybersecurity is that the advantage is by far in the hands of the adversary rather than the defender. The adversary only has to be right once, and if they succeed, they can succeed in their goal. But the defender has to be right 100% of the time. They have to catch every move that the adversary takes in order to actually stop them from achieving their goal. However, that is where our product is designed to actually reverse that advantage. So with visibility into the events that are happening in large environments, real-time correlation, and alerts that pull out malicious activity, we're able to detect all the non-negotiable steps that an adversary has to take in order to do harm, and trigger alerts, remediate them, and prevent them in real time. So before we get into the simulation, Sanat's going to use some terminology, and I just want to make sure we level set on all that so we're all kind of speaking the same language here. So our product is going to pull information from endpoints. This can be servers, laptops, Linux, Mac, Windows, and they're going to run them against some threat intel feeds to pull out just static IOCs, known bad IPs, known bad domains, hashes, etc. Next, that data, whether or not it's deemed malicious, is correlated in our in-memory graph database. Relationships and structure is built of that data so that we can do really useful things in real time. From this structured data, the first thing that we're going to pull out is what is known as evidence. So evidence is things that are happening in the environment that in and of themselves are not necessarily malicious, but could be used later on to give context around a malicious event. So a real world example of that would be like a fingerprint, right? There's fingerprints everywhere. They're not in and of themselves a bad thing, but if there was a crime, you would want those to get more understanding of what happened in the environment. The next thing that we're going to pull out via our analytics engine is suspicions. So these are things that actually are somewhat anomalous. They're not things that you typically would see or should see in an environment, but they're not quite enough to say, raise the flags, we got to dive in here, we're on red alert. And once those evidences and suspicions build an environment up to a point, it'll trigger what's called a malop. So that's a malicious operation. This is a high fidelity alert that uses not just individual events happening, but correlated events, suspicions, and evidence to say with a high degree of fidelity that something is wrong in the environment, what's wrong, and all the things surrounding that are happening. So now that we've got that behind us, I'd like to give it to Sanat to actually begin the attack simulation.
Awesome. Thank you, Dan. So for today's simulation, what I'm going to do is I'm going to show you a setup of two machines that belong to, let's say, just some organization. And those two machines are kind of interesting targets that I have picked. We'll have an attacker, a Kali box that is basically going to run exploits against these machines. And we'll show you a little bit of how Cybereason responds to such threats. So with that said, I'm quickly going to dive into my VM workstation here, make it a little neater for all of us. And what I have over here is the attacker Kali box. It's got a Metapredator listener over here and another Python server just running in the background, waiting for different kinds of connections. What I have over here is our victim who's just sitting and browsing the internet. In this case, let's just assume for this scenario that his name is Robert. He's an executive assistant at this organization, and I've been spear phishing him. Now, he has his email open over here. He's opened up a doc that came across called recruitment plan. And you'll see this is not the most sophisticated phishing email you might have seen, but it's not hard for an attacker at the end of the day to create that. And that is not the point I'm trying to show you. Infection is inevitable. That is what this step is trying to achieve for me over here. So Robert sees this nice, interesting doc, and he obviously is click friendly. So he's going to click on a couple of buttons over here to see what happens and if something shows up that is missing from this document. A more recent one that I've seen that I kind of found interesting in terms of spear phishing was this note that comes up saying that this was built in an earlier version of Excel and looks absolutely like real. So you often tend to click on things that you shouldn't. So now let's go into the attacker side of things and see what's going on. You can see here I have a Python server that has served up an exploit, and it's basically just downloading that exploit onto that machine. It's kind of interesting because the exploit is actually, in this case, a TXT file. Nothing too fancy. I'm just sending down a TXT, which is often not blocked by most enterprises when you think about it. So what I've got over here is a new session that has come in. A session from hopefully Robert, if I was the attacker and I had no idea when he clicked on the email. But based on this, it looks like he actually did. Now, as a first step, as an attacker, now that I've landed into this environment, I do not want to be at the same place I came from. I don't want to be in that same process. I want to jump and hide myself into another process. It's kind of an OPSEC step you take as the first step, because if I triggered any alert anywhere, I'm just going to continuously move across this machine to try and hide myself. So what I'm going to do over here is I'm just going to look at the running processes. Based on the ones I see over here, the one that kind of interests me the most is the fact that Firefox is running. And the reason I picked Firefox is because it's a browser. A browser makes a lot of connections, HTTPS, HTTP, and I have my servers listening on both. So I can just kind of obfuscate my traffic in the browser. So I'm quickly going to do that step over here and just jump into the browser. Takes a second. So now that I've jumped into that browser, I'm going to use a script I already have prepared. And what it's basically going to do is a simple net view on that machine. What that does is gives me an understanding of where I am in this environment, who else is connected to me in this scenario. And you can see over here, we have the second machine that I spoke about, the CEO's machine for this simulation. And I see they're on the same network. Now that I've established that, I want to try and see what I can do on Robert's machine that will add value to me, help me move, either gain privileges, move laterally into Mario's machine, maybe even run ransomware. But I first need to know what his OS looks like. And now at this point, I can just maybe go up to exploit DB find a bunch of vulnerabilities for like Windows 7 Service Pack 1 or maybe even Windows 10, do an AMSI, bypass, try more sophisticated ways to get through these machines. So at this point, I'm going to sit and think about how am I going to gain my privileges as an actor.
So Sanat, you've done a lot of bad things, right, in the environment, to use a technical term. Have these actually triggered anything in the analyst machine so far?
Sure, so let's go ahead and take a look at that right now, Dan. So what I have over here is the Cybereason platform, and I have my sensor installed on these machines, and it's basically waiting and listening in for different activities going on in this environment. You can see over here, I've already been alerted on a couple of things that have happened in this environment. The first thing I see is an Excel, and the second thing I see is a Reg SVR. As an analyst, I'm going to start with the one at the bottom, and let's just assume we had no idea about the attack here. I'm just an analyst. This has shown up in my environment. What do I do with it? When I open up this alert over here, what I get is, firstly, the 5 things I need to know right off the bat. Which was the affected machine? Which was the affected user? So now I know where this incident is starting off from. I know the process that behaved badly in the scenario, which is Excel, and it performed something known as a malicious, performed something called the domain generation algorithm. Now, for those who are not aware of what domain generation algorithm, very briefly, it's basically a technique of avoiding being caught by threat intel. As an attacker, you buy 100 addresses, and then you say, I'm just going to keep one alive. So when threat intel picks up that one that is live, I can spin up another one, and I'll have my algorithm just churning through all these addresses to finally see which one is alive. If it's alive, connect to it. That's the idea of a DGA. So I know now what kind of activity is being performed. I see there are no connections in this scenario also, and I also have a timeline, which is pretty awesome because now I know when did this start and how long till it actually triggered. Over here, you can see that the dock actually was open and kept, and it started off about 34 minutes before the actual infection happened. So a sandboxing tool, if you sleep for some time, malwares tend to do that. You probably evaded a sandbox over there or something. Gives me some idea of what they're trying to do. And the timeline also helps me understand where this is progressing at different points of the chain. And we'll see that moving forward. I have a suspicion that tells me it's a domain generation algorithm. Cool, we figured that part out. Now, let's go a little bit into this process to see what is going on. I see Outlook is the parent. This is Excel. Probably a good indicator that this is a phishing attack, right? As an analyst, now I know what is the entry. Was it a drive-by download? Then I would have expected maybe Chrome or Firefox or a browser to be there. But the fact that I see Outlook tells me it's probably a phishing attack. I can see a bunch of queries resolved over here, and you can see they are just random names. They do not even exist in this case. But what's really cool about what you're looking at over here is that everything I see over here that is in blue is something I don't have to care about. As an analyst, I have to only go and look at the next thing that is red for me. And that way, what happens is that I'm not going down a rabbit hole trying to figure out what is going on in the scenario.
If I can interrupt you again, so it doesn't look, there were no signatures or no static IOCs that were used to create this detection. Can you tell me about how behavioral detections were utilized in this instance?
Sure. So in this case, what we are looking at basically is the activity of Excel trying to reach out to addresses that do not exist. That is one factor we take into account. The engine is looking at that activity, and it does it at a very high rate. Another thing that is really useful in terms of context and bringing in using the context that the engine can get is like using the threat intel feed where it pulled down this hash, checked that the signature is verified. So that means this, now it has confirmed this is legitimate Microsoft Excel. It's not anything fake that has been bought into the environment. It's the real Excel behaving in a way it shouldn't. That is behavioral-based detection, right?
Gotcha. Thank you.
Cool. So let's look a little bit more into what happened next, because that's what the analyst is going to do, right? He's going to go into this Reg SVR and try and see what was going on in this scenario. Now, I know that the screen has changed completely, and so I'm just going to go back to the inbox where I did see the same Reg SVR, because we will come back to that screen, but let's go with the malloc in this scenario. Now, as an analyst, what I have is a bunch of options over here. I can straight away isolate the machine, right? I can go ahead and say, you know what, I don't want to see this activity. I want to stop it right in the bud, go and cut off all communication. I can respond to remediate anything, but let's not do any of that now because it'll destroy the whole simulation. And that's not what I want to have. But I want to point you out to this timeline because it's kind of interesting, and I'm going to show you something later with this timeline. We can see over here that this regsvr malloc that triggered on Robert's machine. Just remember that for now. You can also see over here the command line that was used. I know the IP from where he's downloading his payload. I can go and check now every communication this IP is made and just know to what level am I infected? Where else is he reaching out to in my environment? Now, before we go into all of that, let's go back into the screen I left you off at the start with. So over here is a more detailed view, but what I want to point out is I want to go back to that Excel for something a little more interesting. I saw Excel open these files over here for me, right? I now know this is the document that is creating chaos for me in my environment. So what am I going to do? I'm simply going to hit the prevent button. What the prevent button basically does for me is it tells the platform that from now on, if this doc is trying to open, just don't let that happen. It's prevented from opening across my environment. So to some level, I've even contained the actual attack that is going on. So now that we have seen these couple of activities show up over here, you can also see we have another one that got created when I jumped across machines. I moved from, across processes, I jumped into Firefox. We'll come back to all of this later, and I'll show you more on this, but let's go back into doing the fun stuff of hacking this box. So we left off at the point where we jumped into Firefox, and then we did a little reconnaissance, saw Maria is on the same network, checked out what her configuration, of what the configuration in this case of Roberts looks like. And I am a hacker. I don't work alone in my underground. I have a team. And in the meantime, while we were talking, Dan, they got me a script ready that will perform privilege escalation on this machine for me. So that's what is going on over here. I'm reflectively loading into the process to gain higher privileges on that machine. It's always good to be in that position because then you can perform a bunch of things, right? You can dump credentials, you can move laterally across networks, you can get access to files that you don't have permission to, and that's essentially why I would do this. So now that I've done this, I'm going to make an assumption over here. I'm going to assume that the administrative password is the same on all the machines. Now, many IT organizations tend to do that, right? Because the admin is not going to remember one password for each machine. So he's going to have his password working common across multiple machines. So if I'm in some way able to get the credentials of any credentials of Robert's machine, I can see if I can harvest those to try and get the admin password also. So let's go ahead and try doing that. But before I do that, I don't want to lose access to my box. So I'm just going to create a little persistent step of adding that user into this environment. So I have a new user that's been created. I'm simply going to go ahead and perform my next step, which is a simple hash dump. What the hash dump is going to do, as you can imagine, it gives me password hashes. Now that I have these password hashes, I can just take them against Cain and Abel, John the Ripper, use those to crack the password, get clear text, download, pay, buy a couple of rainbow tables off the dark market, and just like run it against that and crack the password. But I'm not going to do that. What I'm going to do in this case is I'm actually going to use this password hash itself and try to jump across boxes using a technique known as pass the hash. So before I get into doing the pass the hash, I'm going to make a simple change so that I can obfuscate what I'm doing to some extent. What I'm going to tell Metasploit to do now is that every connection I make from my attacker to this organization, do it through my first compromised victim, essentially making my first compromised victim a VPN. This is a technique known as pivoting. And the reason you do this is so that if I, as an attacker, reach directly out to the CEO's machine, it can raise some flags. But if an internal machine is connecting out to a machine in the same network, it kind of is easier to handle my scenario. And it kind of gives me a nice little pivot in the environment where all my traffic can be obfuscated, right? So that's what I did over here. And now I'm just going to do what I said and use those password hashes to move across these machines. You can see over here, I'm going to use the admin creds I just dumped, the password, the admin creds, and I'm telling it to run a command for me the moment it lands on that box. So let's see how that works out, because it takes a couple of minutes.
So while we wait, a question for you. Is this going to be the same stager that you used for Robert, the assistance machine, or is this a different stager?
Yeah, you can see over here, it's populating. It's actually the same exploit file that I used in the first time on Robert's machine that is now going and being used on Mariar's machine.
Right.
Now, the interesting thing about that is that you need to have your system at the end of the day that can support this kind of detection, right? Recognizing or correlating that data tell me that this is the same activity, in fact. And let's look at that just for a real quick second over here. And I bring you back to the regsvr malop that I showed you. You can see a bunch of activity has started to populate based on different actions we did. But remember, I showed you this regsvr and I showed you it was one machine, Robert E. This is the timeline. Remember this. You can see 14 minutes later, I've seen it now on a second machine. In this case, even if you had remediated the incident, you had responded and killed that process at that time, and you had kept it away. At a later point, if the same activity happens, we'll in fact open the malop again to help you understand the context of, like, this is the same activity, we're seeing it again in your environment. And that correlation can only be done when you use the graph database for calculations based on elements like processes, connections, networks, not if you use it for like certain limited use cases, maybe threat intel across your customers, maybe even, I don't know, like when you use the graph from a perspective of everything across machines are at the same parity level. So whether it's Linux processes or Windows processes, you kind of create this environment where you create adaptability for devices anyways, even in the future. So any kind of device that can model the data that way, then you automatically can feed that into the same engine and improve your capabilities as a security tool, right?
So each customer's got their own data correlated in graph database, which enables this.
Yeah, so we use it actually for even threat intel across our customers a little bit. We do have that knowledge, but we also use it in our actual day-to-day of every machine data.
So let me ask you this. Before you were able to respond to that one machine, now you have a malop that has two machines. You can, okay, you see where I'm going with this.
I see where you're going with this. So you can actually do the same actions of remediation, like isolating both the machines at just one.
At bulk. What if it's 50 machines?
Yeah, it doesn't matter.
Okay, cool.
Cool. Okay, so let's go back actually to the attack and then come back to the platform to see what else we have seen. I see over here I've got a new session that's coming, and I'm just simply going to interact with that, do a little check to see who I am. Okay, I'm system user, but which machine? Okay, so now you can see I'm actually a system user. So I've got my elevated privileges already on Mariar's machine using that pass the hash technique. I can do anything. Maybe use Mimikatz, dump a bunch of creds, use some nice little PowerShell, try different kind of power up exploits, see what vulnerabilities, etc. But what I'm going to do in our scenario is I'm just going to run ransomware. I'm going to run a wiper that makes it hard for forensics to break back into what happened in this scenario. Now, you can see as soon as I ran it, it actually kind of stopped over there. It should actually be showing me what all directories it's encrypting. That's kind of weird. But when you come over here and you look at it from the analyst side of things, you realize that we actually suspended the ransomware. And what was cooler about that was that it was done without affecting any files also in this scenario. We detect ransomware based on the way it behaves. So in that case, what happens is that it's not just a hash match where you're dealing with IOCs and all. We see the processes behaving. We see, is this, for example, if you only see the behavior of encryption, you're probably going to land up in a scenario where it's like, yeah, I got an alert because Dell Encryption encrypted my laptop, and it's supposed to do that because I want my devices encrypted. But in a situation like this, we knew that PowerShell doesn't seem to be behaving the right way. The command line doesn't look right. Multiple factors and contexts are brought to decide, is it supposed to behave this way or no? So before we go a little deeper into the investigation side of things, which I want to show you guys, I want to show a little bit on this parser hash because it's kind of cool. We actually get you what machine did it with what process, and also what does the target look like? Who was infected, what process on that? Now I can go and respond and kill those right away, or I can deal and shut down that situation. I can also then go ahead and take this admin credentials. So I know, like, for example, in this case, the administrator has probably compromised the credentials. Let's go change those credentials, check all the other machines that administrators logged into, and then I know to what extent my damage is, right?
Yeah, that was actually going to be what I was wondering. So we stopped the ransomware from encrypting files, right? So that is, could be considered a success. But we do want to be sure that there's nothing going on anywhere else, right? So after you've stopped the harm from happening, how do you take that first step? Where do you start to check if that file is not anywhere else or no other machines have been compromised?
Yeah, so generally the way you do that, a more of a post analysis, if you may, can be done in multiple ways. I would say a great place to start, especially on this platform, and one of the things I love about it is the simple terms you introduced the audience to in the start, right? We spoke to them a little bit about suspicions. Now, suspicions are activities that are not normal in your environment. And we use that intel to decide if it is bad enough or not. And I'll show you, and we come to another example of how you should handle your suspicions rightly. But let's just start with the suspicions I see here to do a little more forensic / trying to understand what is going on. So a little more of hunting myself. And mind you, these are questions that the engine has already asked of this and alerted you upon, which means threat hunting to some level is easier for me now because the engine has automated most of it also. When you would go ahead and use threat hunting is after the case of remediating all of this and you just wanted to learn more about your environment. You want to know more, right? And we come back to the screen where we actually perform most of our threat hunting in the platform. It's called the investigation screen. It's kind of a nice UI, but what I like the most about it is that you can visually imagine this to be like a graph in which you're just jumping from one node to another node. And you're wanting to ask questions. Oh, this process made this communication. Is the communication inside or outside? Show me all the outside communications. And then from there, I can still keep going on to say how many of these are legitimate, how many are bad. You can do multiple things over here. But what I'm going to do is I'm going to take the CMD that I've started up over here, my investigation with. I clicked on a suspicion over there. Now let me show you what suspicion I clicked on because I missed that out. I clicked on a suspicion that says this process is executing malicious floating code. What that basically tells me is that this process loaded some code into it, and I can then go ahead and try and identify what was this malicious code looking like. So the way I'll do that is, now that I've filtered by that process, I'm just going to click on give me every module it loaded, right? It can be floating, cannot be floating. I want to see every module that is loaded. I can see there are a bunch of them over here. There are about 78 of them. kind of interesting to go through each of them, but I'm not going to do that. I know the platform told me something was floating, which is not normal for CMD to be loading. It shouldn't be loading floating modules. So I'm going to click on show me what is floating amongst these. You can see there are 5 results over here. And some of these, if you actually look at them, they kind of indicate if something is not okay. There's a CVE number over there. There's priv, there's x64 DLL. Kind of bad, right? But what do I do with this data? Now I know that these are the bad modules that the process loaded. I'm going to ask a simple question saying, did any other process do this in my environment? And you'll see over here that straight away I know now that those floating modules actually were on 5 different processes. I can now understand the extent to which he's going. And I'm doing this in a matter of seconds. So for an analyst, giving them the capability to also go through the data the engine is churning through anyways is also very useful in this platform.
Can I ask you to go back to the MalOpen box? At one point, you created a persistent user. Why was there, that to me seems like a malicious activity. Why was there no alert on that?
Okay, good catch, Dan. So yes, we didn't trigger on that. And let's look why. Let's try and understand that. Let's go into this investigate. This was the CMD that actually did it, we know. You can see it's got a child over here, net.exe. We actually picked it up and we even flagged it. We flagged it with a suspicion. Net.exe did something suspicious. Now, think about this scenario. What did it do? It actually tells me it's a descendant of a suspicious process, and also the fact that it added a user to a group. Administrative people tend to add people all the time. If I alert you on every single time an administrator adds a person, you know what's going to happen to your malop inbox then, right? So in this case, it is suspicious, and we've noted it is suspicious, and we have alerted even on the parent process that was bad in this scenario. You can also, in fact, see the command line that was used. So now I know this guy, this user called Ghost, if I see him anywhere else, he's probably bad for me.
So fair enough, if you wanted to set up an alert for that, is that possible?
Yes, you can. We provide you a capability of being able to write your own rules. So that way you can write your own rule for this scenario. And in fact, you can even remediate the rules in an automatic fashion. So if you know something for sure is not good for my environment, you can create your own custom detection for it.
Is there a way to deal with the fact that creating an alert every time a user is created, you're going to get too many alerts, alert fatigue? Is there an option for that?
Yeah, for sure. And we actually do this in a really good way. Let me show it to you here real quick. So the way we handle our whitelisting, if you may, is using behaviors. I don't think I've seen this pretty much out there in any other thing, but you can basically go ahead and create your own rule over here. The root cause can be anything. You can pick whatever you feel like as the main cause for that activity. And then you can say, behaviorally whitelist only this one scenario, this machine, this process. That way you are fine-tuning the way you're whitelisting also. So if something is a little off from the whitelisting also, you still detect it as something bad. You're not scared that you've whitelisted everything and the attacker is going to find a way to go past those whitelists. Use those techniques, cool, if you know what I mean. Cool. So another thing that I'd like to point out over here that is kind of good to know is a little bit more on this pass the hash. We spoke about it already, but the good thing is that you get the correlated timeline even for that. So when you see activities happening across multiple machines over here, like the pass the hash, we got it for that activity too in this scenario. But that is pretty much what I had in mind for today. Let's take it a little bit into wrapping this up.
Thank you. I learned a lot. Definitely not going to give you my home Wi-Fi password, so that's probably the most important thing I learned today. Anyway, so just to wrap things up a little bit before, I think we have some questions coming in. Before we do, I just wanted to go over, what we saw was that's an advanced persistent threat. And all those things that were done were alerted on in real time, and they were alerted on behaviorally. So we're not relying on signatures or IOCs in this case. while they are utilized to reduce the noise in an environment, they're not going to get you all the way. And that's where we believe that the proactive approach is the key to preventing these threats. You want to be alerting on things and you want to be able to react to those instantly, but you also want to be able to proactively move through your own environment, see what's going on, and really see the relationships between those things. A lot of the things we saw in and of themselves are not enough to tell a story. And it's a lose-lose if you're only looking at them by themselves, because if you alert on every single one, you're going to be drowned in false positives. But if you don't alert on it, you're going to miss it when it's adjacent to other activity that can tell the whole story. So thanks everyone for listening in and experiencing that attack simulation, and thank you, Sanat, for doing the attack for us.
Yeah, so we had a bunch of questions come in, and the first question is for Sanat. Wouldn't the malicious Excel macro have been blocked by NextGen AV?
Yeah, for sure. So it's great question, for sure. And that's the point, right? Infection at the end of the day, to some level you can detect, but not everything. Because if I use a more sophisticated payload that is really well encrypted, it'll bypass all your AVs. Oh, rather than that, I'll just buy your AV. I'll just figure out what AV you use, buy it, test it like 100 times, get past it, figure out a way around it, and just send that. But yes, in this case, for sure, in our scenario, the AV actually did pick up on the multiple activities I performed, not only the file-based ones, but some of the file-list-based ones also that I performed.
Thanks, Sanat. So yeah, it would have prevented it. We turned it off for the purposes of this demo, but the point needs to be made that we need to be ready for things that can't be prevented.
All right, and the next question is, how is this different from a SIM and all the data I see in there?
Okay, so I quickly went over like pivoting on the investigation screen, but just real quick to show you a little bit on like, since this question came up, you essentially see a lot of data over here being used, and like you can see everything that was used in this scenario. You can see much more detail. You'll probably think, yes, it's similar to things like maybe a SIM where you see different kind of logs. But remember the fact that the way you model and structure your data is also kind of important, because even if you manage to pull all this data into something like a SIM, if you don't have the right data solution, I mean like a big data solution to correlate and handle this data, you won't be able to do this in a SIM in an automated fashion in real time. That I would say is one of the biggest differences. Pulling the data is one aspect, and solving the big data problem in terms of a cybersecurity aspect is a different one.
Thanks, Sanat. And actually, along these lines, we appear to have another question about using our product alongside SIM like Splunk. And that's absolutely something that can be done and is often done. We have an integration that you can use. And we also have an open API for integration with any other SIM that we might not actually have an out-of-the-box integration for.
Yep. Our API actually feeds everything we see in our graph, so you can have all the data that Cybereason is looking at.
Great. There's so now we also have another question about how we gather our data. We said that a little bit generically, but the answer is we have an agent that we deploy to the endpoints, and those are going to collect the data for us. And that's where it's sent to the graph database that can live on-prem or in the cloud, and that's where all the correlation and detections happen. And that's where you get to hunt through the data is when it's actually already structured in that graph database.
All right, so another question is, how long would an attack like this take to carry out?
So I think it depends on the way it is done, in the sense that there are probably like, see, if you take like something like a bot or a botnet running around and like spamming everybody's machines all the time, it's probably got a bunch of inbuilt exploits. It's going to try those known techniques and try and like get into your machine. The other kind is the more sophisticated ones, where you try to like mix with the noise of the environment, if you may. Like the guy who's going to go ahead and use something like NetView or NetUser and lay off the LAN tools. That's what I try to do over here, use as many inbuilt ways I could. That is the more sophisticated actor that probably takes at least 100 days. A bot is just going to keep hitting you most of the time, and that is probably in seconds, which means for both scenarios, you probably want to detect it within seconds. That's the easier way to look at it.
Got it. And were you able to find attribution?
It's kind of interesting, right? So attribution is I feel like it's very useful, but not when you're dealing with an incident. When you're dealing with an incident, I could probably like just open up MITRE right now and look for that reg SVR technique that I use and see all the groups that use that technique. But what am I really going to do with that? I mean, I could be APT group 3 pretending to be 5. I can change who I am. It's useful for sure, but not when you're dealing with an incident that is like burning your house down.
Yeah, I mean, an analogy you could use for attribution is if someone's inside your bank actively robbing it, you're not going to try to figure out who he is. You're going to spend all your time and resources stopping him. Now, after you've successfully stopped him and you didn't waste time figuring out his name or what country he's from, that's when you can work on attribution. So that's absolutely something you can and should do. But for this demonstration, we wanted to focus on what the adversary and the defender are doing in the moments when your business might be compromised.
So another question we got was, what happens when an endpoint is offline?
So when an endpoint is offline, we are still collecting the information. And when it comes back online, we push it up to the cloud. And then it runs through the engine.
And all the preventative capabilities will be functioning at that time. So as soon as they're back online, we will be able to collect all the information that was gathered from the machine.
Yep.
And then can you automatically stop these things you're detecting?
Yeah. I think Dan brought this up earlier, but yeah, for sure. I mean, when you write a custom rule, it actually gives you even auto remediation. So you can actually prevent these as they're happening for sure.
Okay. So we have time for one last question, and that is, how do you deal with false positives at Cybereason?
So false positives, I mean, it's kind of interesting because the way we write or the way the detections are structured are not designed for, I would say it's designed for every organization without taking the nuances into aspects, right? So if you are a firm or an organization that doesn't like a certain kind of activity generating an alert and it's normal, say you're a bunch of developers sitting and creating like files on the fly every time, or you're doing malware testing, you're a malware researcher and you keep alerting, like keep popping alerts in the SOC, it's not a great situation. That's where I've seen like false positives come up quite often. And in that scenario, I would say use the behavioral whitelisting that we have. That's how we look at it. We don't look at IOC based or like, we don't look at it as black and white, if you may. We kind of understand that sometimes you might have a gray area and you got to work around it. So we give behavioral whitelisting to achieve that.
Yeah, and I think this is also, again, to keep coming back to correlation and context, that's where this comes into play. If you're actually adding in other factors that an actual analyst would then go in to figure out, to find out if it's real or false, when we do that in the product, it helps to reduce the whitelisting or the need for or the amount of false.
So great point, Dan. And like, I will also say, like, when you have that correlation and the data understanding, like how I was saying, or the data model in that fashion, it kind of leads you to the point of, let's think about it this way. I feel like our founders solved the harder problem first. What I mean by that is that they understood how can we model this data so that it can be used for anything. Today, it's for desktop servers and cloud-based servers also. But our data is not really dependent on the OS to some level, right? I mean, the engine, the core of it, you feed it the data how you would like, how it should be fed, like segregated as processes, networks, connections. It can be a mobile phone running processes, networks, and connections, and you can feed it into our threat hunting engine. And kind of that is actually seen, I guess, some of you might have heard of it, but more recently with our tie-up with ARM, for example, we can just ingest that data into our graph and start detecting malicious activity on devices that use ARM chips, for example.
Yep.
So we actually went ahead and solved the bigger problem first of how do you manage or correlate this data. And that I feel is kind of very important to understand.
Absolutely.
All right, thanks everyone. If we didn't get to your question, we'll follow up with you shortly.
All right. Thanks for listening.